Hey all, welcome back to my channel. In this tutorial, I'm going to demonstrate how to produce one sample t-test in Stata. So in order to do that, I'm going to use a variable called BP systole, which is systolic blood pressure. So I'm going to compare the average systolic blood pressure of the sample in my data set with a specific number, which is 120. And 120 number is kind of medical standard. So we want all our systolic blood pressure to be 120. So we want to compare if 120 is significantly different from the sample mean, which is the average of this sample um, in our data set in terms of systolic blood pressure. Okay. So now let me write the command T test and then BP systole and then equal 120 and hit enter. Okay. So the first question is, what is the average value, or what is the average BP systole or systolic blood pressure of the sample in this data set? So we have 10,351 people or observations in our sample, right? And they have on average 130, or you can say 131 systolic blood pressure. We know that is different from 120, and you can see we specified this value. So the purpose of one sample t-test is to compare your sample mean with a specific fixed or known value. So we know that 120 is the standard. That's why we're comparing this number with the sample mean, which is 130. But in our casual observation, we can be sure that there's a difference between the two, right? Because 120 is not the same as 130, right? However, we do not yet know whether these two numbers or these two two numbers, this sample mean, is significantly different from 120. So whether this is a statistically significant or not. So that question can be answered by p-value. Okay. Of course, p-value is associated with the t or t statistic, but we're gonna explain the p-value. So for now, look at this middle one. There's p-value here, there is p-value there, okay? But we're gonna focus on the middle one first, because you see the number t, the capital T, and this bar, this is the symbol of absolute number. So the absolute number means you ignore a plus or minus sign or negative or positive, right? So that means this one is not directional p-value or directional test. That's why it's called two-tailed test. Okay, that means there is no direction. But here there's a positive direction. We're specifying that this t is greater than this small t. I'm not going to explain these technical details. And this is the negative direction, meaning that they're greater than zero, and this is less than zero, right? Which makes it negative and positive. But this is the expected one. This is the best practice model to produce something that is two-tailed, but it could also do one-tailed if you were interested in knowing whether they maintain a particular direction or not. But for our purpose, we want to know if the mean of the sample is significantly different from this number, which is 120. And the t-test confirms the p-value, which is 0.0000, which means this is less than 0.05. And anything less than 0.05, as I told you before, is statistically significant. So we confirm that our sample mean, which is 130, is significantly different from our specific and fixed known value 120. Okay, so this is the purpose of one sample t-test, which is to test whether the sample means is significantly different from a known value. In our case, this is 120. Many people struggle with how we determine like this number, right? What does this number come from? This number comes from theory or medical guideline or policy prescription. It could be informed by many factors. But in our case, it's a medical standard. We want to know whether our sample mean is different from this medical standard of 120 systolic blood pressure. Thanks for watching, and if you really like my video, subscribe, like, comment, and share. Thanks.